Be going on to the next talk, a very important talk for all of us because we're going to talk about trees and our changing climate. I can welcome Markus Voss von Birds on Mars, a very catchy name, with a talk on Can AI support our trees, city trees in changing climate. Markus is an AI expert and intelligence architect at Birds on Mars. Before, he was a research associate at the DAI lab at TU Berlin, where he led the research group Smart Energy Systems. He also volunteers as a community lead for building and transport at Climate Change AI, which is an international organization bringing together researchers and practitioners in machine learning for climate change mitigation and adaptation. Thank you for being here today.
Sure, thank you. First of all, I have to excuse my voice a little bit because yesterday there was a very big basketball game in the arena, like Greece against Germany, and I was in the arena, and this was not a very good experience for my voice, even though Germany played a great game. But anyhow, it's great to see these great industry applications of AI. I've always been fascinated by AI, data, machine learning from the first steps I took with IBM, working and improving business processes. But what has been driving me more over the past years is how to apply AI, machine learning, data science to the most pressing problem that I find is, and this is climate change. I mean, it will affect us all, and that's why this has been motivating me. Do I think it's the most important tool to address climate change? No. I've also tried other things. I also tried to go into the energy sector. I tried to join a party. But then always I noticed my strengths are just solving problems with data, so I always resorted back to that. And so this has been a little bit the history that you just heard, like starting with the seminar thesis about modeling electric vehicles, then as a research associate in working in smart grids with power system data, and now more recently also with our clients at Birds on Mars, where we want to apply machine learning and AI for sustainable use cases. So you've seen the talk from Deutsche Bahn, for example, earlier, where we're working together with Deutsche Bahn. And yeah, in my work also at Climate Change AI, I want to enable also others. But let me introduce you to one of the, actually, this is a spoiler here. Sorry. Let me start by talking about our city trees, of a project that we did with City Lab here in Berlin. So actually, yeah, now this was spoiled a little bit, but what I wanted to do here is actually also, I mean, you've seen DALL-E quite a bit, and I just wanted to share with you my latest jaw-dropping moment of AI, basically. Like I said, it's spoiled a little bit. So this is actually the starting slide that I've used all the time in the past year. So this is a lamp we have in our office. We have a lot of like birds and Mars-themed things in our office, and we kind of like that. And when DALL-E came out with the outpainting feature, then I was kind of interested in, okay, could I also have a lamp that looks like planet Mars? And so this is something that I just typed into DALL-E and asked it to produce a lamp that looks like Mars. And so this is what it came up with. So this is a lamp that doesn't exist, and it's pretty cool. Like I actually would want to have that in our office. And then I continued and thought, okay, what else could there be in this setting? And I asked it to generate a cute toy robot, and this is what it came up with. And so this is very impressive, and I mean, this is really cool, and I really want to have this robot, and I mean, at one point I hope to maybe I can build it. Now you can ask, okay, what does this have to do with useful applications? Isn't it all like fun and games? What could it even have to do with climate change? Well, like with many other technologies, when a lot of smart people are working on something like this, which is very impressive and gives you those jaw-dropping moments. There's also some technologies that are developed that you can also use for other purposes. So for example, the same sort of generative models that have been used in DALL-E, so this is diffusion models, and we used a very similar model. It's normalizing flows. Like if I would write this paper now, I would probably use those denoising models. Can be used to generate forecasts for electricity systems. So what we did here is, you see all these small gray lines, which are just learned samples of this distribution, and they can be used to inform optimization systems in energy systems. And instead of cute toy robots, you're basically generating realistic scenarios of how the power consumption could look like on the next day. yeah, this is something we did within the project back when I was at TU Berlin. It was a Syntec project, so one of the big intelligent energy system projects, and we applied these forecasts together with partners in building energy management systems. But actually, you can also use these models more direct also in climate change. For example, to use this to raise climate awareness. So here you see an image of my street in Schöneberg, Belziger Straße, and I basically just asked Dali, can you please flood my street or can you just burn my street? So this, I just did typing, so there's no Photoshop involved. I mean, the one on the right looks a bit weird, but the one on the left is kind of impressive. So I mean, it looks like my street is flooded, and as far as I know, it hasn't. So of course you can create these disruptive futures, but you can also create more positive futures as well, right? So on the left, I asked it to remove all cars and have people walking there, and it's also pretty cool. I mean, it now looks like, if you're from Berlin, like the Kiez in Kreuzberg or something. So this is much more livable now. On the right, I asked it to put moss on the street, which is kind of defying the purpose of the street, but it is still pretty cool. Okay, but now from those fun and games and this introduction, I want to go to the actual project that I want to talk about. And this is the project Quantified Trees, or as we could call it, Q-Trees. It's a project by the City Lab Berlin, Technologiestiftung Berlin, us Birds on Mars, and the City of Berlin, so the Greenery Department of Berlin. And it's funded by the BMUV now. It used to be a BMU. And so what's the idea there? I mean, first, let's start with the motivation again. So, I mean, we all know that, and you can feel it. I mean, this is the data up to last year, and I think this year we're going to add one more very dark red stripe to the right there, because, I mean, this year, again, has been exceptionally hot also in Berlin. I mean, it was very tropical in Berlin, it was hot in Berlin, it was dry in Berlin. So climate change is not something that's far away, it's something that's also affecting Berlin and Brandenburg. And this also affects the city trees. So, I mean, it has been very, very dry. So in March, it didn't rain at all. I think it was just 1 millimeter here in Berlin that we had. So that's really not a lot. That's like almost no rain. And then also the summer was very dry, and we didn't have much water. So the greenery departments have to water the city trees, because the city trees that have been planted some 50 years, 60 years, 70 years ago are now not used to this changing climate. So they need water to survive. Also, we're making it very hard for those trees because we're sealing the surfaces, we're putting up glass fronts which kind of mirror the light to the tree and make it even more dry and everything. So what we want to do is, what the greenery departments are doing, like I said, they're putting out 200, 300 liters of water per tree. We have like up to 1 million of trees in Berlin, so that's a lot of water. So what we want to do is we want to give the greenery department some decision support system that can help them do this a little bit more fine-grained, because when we talked to them, we figured out that not all of those trees need so much water, but it's just easier for them to do that. So how are we doing this? Well, of course, we need some data. Of course, we could put sensors everywhere now, right? But this would be very unsustainable. I mean, this is like putting a lot of hardware everywhere to every tree. This is very unsustainable. But what we do is we put, or actually the greenery departments already did that, put some sensors to some of the trees. So in Berlin Mitte, actually also a little bit more to this side actually, and also Neukölln. There are about 100 to 150 trees now that have some sensors like this, like you see there, deployed in like 30 centimeters, 60 centimeters, and 90 centimeters. And we're measuring how dry it is in the ground. And then we want to use this information to generalize from that to all the other trees in Berlin, to then make a decision support system. How are we doing this? Well, we use weather data, of course, because this is one of the most important influences. So we can use, for example, here the radar data, as you see it here, in a grid, 1 by 1 kilometer over Berlin. So you can also distinguish that, for example, some rain was only falling in parts of Berlin and how much came down. So we're using this data. Then we're using, of course, the watering data. There we get the data from the greenery departments in some structured format. Semi-structured. But there's also this Giesting-Kiez. And Gießen Kiez is another project by the Technologiestiftung Berlin, and it's actually where people can go out, water the trees, and put this data in there. So we can also use this data. But it's actually only in part of Berlin where there's some data, because there's some areas where people use it more than others. Then we can use open data. Berlin has a lot of open data, especially on environment. There's a lot of great data. It's just very hard to find, actually, because the user interfaces can be a bit clumsy, but there is really, really great open data. So we have data on all the trees, like on 800,000 of the trees, we have the data. How high are they? What type they are? How old are they? And so on. And then one thing that we had to do, because when we talked to the experts, the domain experts, we actually learned that if a tree is standing in the shade or not is very important. So this is actually having a large influence on how much water they need. So what we did is, again, we used open data of the height of things in Berlin, and then used, basically physics to calculate, because, I mean, we can understand where the sun is going for many hundred years now, and to calculate something what you see visualized here. So we call it like a shading index, which is basically everything that's white has 100% of the available sun of a day, sun hours basically, and everything that's black is like none of the sun hours. So here you see the Strausberger Platz, which is just over there, and you can kind of see that the southern part of the street is very dark, so that means there's a lot of shade during the day, and all the trees standing in the shade should not need as much water as the trees which are in the north of that street, where you need more water, basically. And so we use all this data and then give it into, well, the AI box. I mean, it's random forests, which is also nice from the meta level, because you have trees making predictions about trees. So that's kind of cool. But it's actually a very useful algorithm also for structured data. And then we do like nowcasts, so meaning we predict what's happening right now, but we also do forecasts, so we try to predict based on the weather forecast what's going to happen in the next days and weeks, depending on how good the weather forecast is, to give the greenery departments, like I said, a decision support system. But actually what we also want to do with the City Lab is to give the citizens access to that data, to our predictions. So we have an app which will be coming starting next year sometime, where you can basically click on every tree in Berlin and get some prediction based on our models. And also some explanations on why we think this is the prediction. So follow our project for that. So let's generalize a little bit from this project and get to some general points. So should AI be applied for climate action? Well, just as we used time series forecasting here and used that for climate adaptation, basically, there are a lot of other areas also in companies and also in your companies where AI can be used, right? There are a lot of different AI techniques that can be used to save energy, which is very important in the next winter, and improve things that are climate relevant, which we call here AI climate action potential. And more on a global scale, like I said, I'm working with Climate Change AI. Also follow, like if you're really interested in this, go to our page here. So here we had the right screenshot is from a summer school that was 2 weeks long, where we talked about so many different applications of AI in the climate space. So yes, there are a lot of cool applications, but I want to finish with some last thoughts. So for me, if somebody asks me what AI is, I'm a data scientist, so for me AI is like a tool or like a toolbox, and I mean we can debate if you want to count linear regression in there or not. It's a toolbox, right? So it's tools. And it itself is neither good nor bad for the climate. So thinking of the analogy of a tool, you can use the tool to fix a bike, but you can use a tool just as well to steal parts of a bike, right? I mean, the same tools can be used for that. What I mean here is you can also use AI to do the exact opposite, right? So according to this Greenpeace report, some of the bigger companies are also doing this. They're using AI, data platforms to support the oil industry to look for better for oil, more efficiently for oil. So you can, of course, also do the exact opposite. And one thing that I also want to highlight is that, of course, AI will only be one part of an overall strategy, right? So when working with the greenery departments, for example, we're not claiming AI will save all the trees, right? So it will only be one part that makes their decisions a little bit more efficient, saves some water, but in the end, all the good work that the greenery departments are doing is much more important, of course, than AI. And also here, if you take the background image here, this example is from solar forecasting. So this is Open Climate Fix, an NGO in the UK, which showed that machine learning can do pretty good predictions for solar panels. And yes, it's a nice tool to do this, but in the end, solar panels have to be out there first. So if there are no solar panels, AI can do nothing, right? So you need engineers that are working on the solar panels, you need politicians that incentivize to put solar panels out, and then AI can also do its thing and make things a little bit more efficient, right? So it's always just a part of an overall strategy. And also something when you're like really coming more from research, it's also hard to swallow this one. You have to be like, if you really want to solve a problem, in the end you also have to be okay to not use AI at all, right? First thing when I thought, hey, we're having all this time series data of trees in the city, I was like, hey, let's use some graph neural networks, whatever. But if you're then noticing that random forests do a good job, then you have to be okay with it. If I find that some simpler time series model is doing a good job, I have to be okay with it because I have to be interested in solving the problem and not running around with my fancy algorithm and looking for problems, right? So sometimes that's just a more efficient tool to solve a specific task, right? And one final thought to wrap this up. When working with AI in climate action, it's inherently interdisciplinary. So this is something I've been noticing in the past quite a bit. So you will never be this one person that knows everything of electrical engineering and everything of machine learning and can solve all the really big problems. So you need to collaborate and listen to experts, right? Because otherwise you're solving just the wrong problems, or you're just solving the not relevant problems, or you're just solving it in the wrong way somehow. So that's why before we wrote any line of code, looked at any data, we talked a lot to the greenery departments, to gardeners, to people that know already the domain, filled a lot of mirror boards that you see in the back here, and we filled even more. And then only started to write any code and any data to then create a really good solution or a product for those that can use it in the end. Thank you.
Thank you very much. I'm going to look around if there are any questions from the audience. I will for sure be waiting for the app and checking out if the trees in my area need watering. So thank you very much. Now, I want to... Oh, there is a question. Excuse me.
Hi, so thank you for your talk and thank you for mentioning efficiency. You said AI is neither good nor bad for the climate, but there are these calculations of carbon footprints of something like GPT-3, and they are enormous, right? So what would you say to that?
Yeah, it's a very difficult topic, and I mean, I couldn't address this whole topic. Well, I think the discussion there ranges from, I think there was a number quoted, heavily misquoted actually, from training an AI model emits as much emissions as 5 cars in all their lifetime, but this was very focused on one specific architecture search project. And then recently Google posted a headline which is basically saying, this is not a problem at all and it's solved and we shouldn't care about it. And somewhere in between there's this debate. Yes, GPT-3 takes a lot of energy to train, but then you have to also think about these big models, how they're used, right? I mean, they're trained once, and then typically, like, let's say, take a language model, like, let's say, a simpler one, like BERT, and it's trained once, and then typically for your applications, then just fine-tuned a little bit. And this fine-tuning step is actually not a lot then. So the big training happens once, but for a lot of applications in a lot of companies. And so actually what's also more interesting is now, how expensive is the inference? So actually these diffusion models are very expensive at inference time. So this is actually much more relevant than the training, which today is talked about. But there's a lot of data missing actually about that and what it means in practice. So if anybody of you has data on that, I'm happy to also connect you to some of the researchers working on that, because Lynn Kark, for example, from Climate Change AI, works a lot on that. And it's a very interesting topic, but it's also very complex. Yeah, thank you. But for example, BIRD, fine-tuning it is about as much CO2 emissions as a gallon of gasoline, for example. So that's like, I mean, people drove here today probably using more than that. Yeah.
Thank you.
But wouldn't it be necessary also to take into account the hardware you use for AI? It's not only the energy for using it, resources and all the stuff.
Yeah, definitely. It's like I said, it's a complex topic, and we can't solve this today. And I'm happy to discuss this with you and or connect you to also to others that are working on this. Yeah, of course, it's the embedded footprint, it's the training of the model, it's the inference of the model. Then it's the application layer, basically, like what is the application doing, how much is it saving, or maybe even harming, like I told you. And then you also, I mean, there's another layer, which is, for example, rebound effects. Just because you're suddenly doing something more efficiently, you're saving energy, and suddenly you start doing things more often, and then in the end, you're not saving anything. One example is lighting, for example, because lights have been becoming more efficient, and now suddenly lights are part of interior design. You're just putting out a lot more lights. So in the end, you're not saving anything, like in some. So it's kind of similar to that, yeah.
Any more questions? I think in that case we're done for today. Thank you very much. I want to say thank you to all our amazing speakers today and their insightful talks. And also thanks to all our partners, our premium partners, Accenture, Dataiku, Nodo, Dean, Fivetran, Google, Oleg, and Staful, our other partners, and also our media partners. But indeed, we are not finished yet. We still have a networking powered by Accenture in Almaty. So please have a drink, have a snack, and let's sink in what you heard today. And please do make sure to come back tomorrow for the second day of the Big Data AI Summit. And please do also leave your feedback on our Swap Card app. Thank you very much for being here today.